page. Oh, never mind. Sorry. It just took some time to populate. I was starting to think, oh no, why isn't it going? Okay, we are live. So I'm going to mute myself and let you all take it from here.
Awesome. Hi, everyone. I am Abubakar Siddiq Ango, a HashiCorp ambassador. We are excited to have you on today's awesome event, HashiTalks Africa. It's awesome to have the great speakers we have lined up. Also with me is Olubusayo Amowe. Busayo?
Yeah. Hello, everyone, and welcome to HashiTalks Africa 2021. So we're just going to go right into introduce our first speaker, right?
Yep.
Okay. So our first speaker is Paul Zietsman. Correct me if I'm wrong. Did I get that?
Perfect.
Okay. So Paul is going to be talking about Terraform. So I've been looking forward to this talk because the topic looks like really catchy. And Paul is going to show us how we automate everything Terraform related. And he's going to also give us a startup project for us to get along with. Paul is passionate about blockchain, software development, mountain biking, and you occasionally write code. So, Paul, you have the floor.
Yeah, before Paul starts, please let's also remember to follow our community guidelines. And if you have any questions, you can always drop your comments in the YouTube chat and we'll be there to answer any questions you have. Over to you, Paul.
Awesome. Thank you, guys. Yeah, so I hope the title is a bit catchy. It was a bit of a clickbait one. So yeah, and thank you for the opportunity. Today I want to talk to you about how we automate the creation of our Terraform infrastructure. So it's a bit of a weird one. I think a lot of people don't think about how do you actually manage the infrastructure that manages your infrastructure. So that's what we're chatting about today. And then I want to show you just some things we've done internally in our company to standardize and make the adoption of Terraform a bit easier. So just a quick blurb about myself. Paul, I am the co-founder and technical director of a company called Cloud and Things. We're 2 months old maybe, Cape Town based. And like they mentioned, I'm a dev. I'm passionate about a bunch of stuff in tech. Yeah, and HashiCorp is something I naturally gravitated to. I love what the company is doing from a tech point of view and from a culture point of view. So just to give you a bit of background about myself, I've been part of in a previous life, I was an electronic engineer and I became a full stack engineer. And then I gravitated into AWS and into becoming more on the infrastructure side of things. I've been part of the core infrastructure team at quite a few companies, doing a bit of consulting. In those teams, we mainly cared about networking and security, laying the baselines for the rest of the organization. And these environments varied in size from a few accounts to a few hundred accounts. And we worked in environments where we had more than 1,000 Terraform workspaces running in Terraform Enterprise. That's kind of where how you manage those things become quite important. And then also, I've been in the big data teams where we did on the infrastructure side in AWS for next generation big data platforms, and I do application development internally in the company. We've got a few products we're building, and we use Terraform to manage the infrastructure for all those things. So across all our clients and all the projects we're working on, we've got way more than 1,000 workspaces we have to manage. So just a bit more background, like I said, deployments across hundreds of accounts. In most of our environments, we use a IAM hub and spoke design. So we put a central account where our root credentials live, and from that account, we assume roles into sub-accounts to do deployments. All our clients are either in the financial services space or in the medical space. And so security is of like utmost importance. So rotating credentials is something we have to do like often. We do it as often as possible. And then like that in itself is quite a big problem if you've got 1,000 workspaces to manage and you don't have a nice way to roll out new credentials. And then Git is our source of truth for everything. Our documentation lives in Git. Our obviously our Terraform infrastructure lives in Git, and our application code sits there. And then like how we manage Terraform, we wanted to get that into Git as well. So like a bit of the problems we've ran into over the past few years. So we started with Terraform almost 4 or 5 years ago. And back then we used to do local Terraform runs. And like sometimes like we're all eager to get on the latest version of Terraform, and someone would bump a state file to the next version, and the entire team needs to upgrade their Terraform versions. We had state files living in all weird places. Some people pushing it into Git, some people keeping it on their local machines. Like sometimes it sits in S3, sometimes these like state locking is enabled, sometimes it's not. So like there was a lot of drift in how we managed Terraform in general. Then when we started adopting Terraform Cloud and Terraform Enterprise, we saw like how people were manually going into Terraform Enterprise and into Terraform Cloud and creating workspaces, and these things weren't set up uniformly. So you could pick up one repo and the naming conventions were weird. And like that overhead as a developer, when you're switching between all these code bases, like it's something that's looked over quite easily. Like that there's quite a bit of overhead. You can't just pick a repo up. You actually have to think, like every time you want to make a small change, like you have to be careful because you don't know if this variable that is exactly the same named as another variable in another workspace, it's going to do the same thing. And we found the same thing with our AWS accounts. We found that AWS accounts are just being created, and like it's poorly documented why it was created and the configuration for that account. Yeah, and then Terraform Workspace is not being set up correctly, like in general, because we've got this IAM hub and spoke. People would not have access to those credentials of that hub account. So they would just create credentials in the account they want to deploy it into, or they generate new credentials and basically expire the old set of credentials, which means all other workspaces stop working. So it was just a mess in general. So like what changed for us, so Terraform Cloud and Terraform Enterprise, like the adoption, when we started using something to manage our Terraform, that was like a 0 to 1 movement for us, and not having to run Terraform locally, having something that manages our state, and that changed the world for us completely. The problem we had then is that it's so easy to create workspaces, and there's a cost involved, that there was quite a bit of sprawl involved. And then Terraform 13 came out, which was a big change for us as well. Suddenly we could create custom providers to do things that we usually had to do in other systems. Like an example of this would be our like spinning up AWS accounts. We did that in an external system, and just having easy access to all these providers. Providers has been part of Terraform since quite, like I think probably not day one, but early on. But getting custom providers into your workspaces was tricky, and Terraform 13 just completely simplified that for us. Also, after Terraform 13, it felt like the Terraform registry just exploded with really good quality modules. So stuff that we used to maintain ourselves. A stupid example would be like something like spinning up an RDS database, would be stuff that like we would have our own like RDS module. Now there's so many good examples of something like spinning up a AWS RDS database that we can pull it from the registry, which was great. Module looping was a big thing for us because we had to do like really weird stuff to simulate like looping over a module, especially when our first pass at creating something that manages our workspaces for us. That was quite a hairy piece of code to work on, and introducing new variables into the templates we built was tricky, and module looping just simplified that for us. And then variable validation. So we could now, like, we used to build these guardrails, and I'll show an example of a guardrail that we still use. But we used to use these guardrails within our code to create exceptions within Terraform during runtime if a variable doesn't meet certain requirements. But now we can do it like in the variables, in the variable definition, which is like much cleaner than what we used to, and much easier to ensure that it's being followed through new repo. So these, like this combination of Terraform Enterprise and / Terraform Cloud and Terraform 13 really like supercharged our drive to automate everything we do Terraform related. So we went and like terraformed all the things. So we have workspaces that creates and manages all our other Terraform workspaces. We've got workspaces that manages the creation of AWS accounts. We created a custom Terraform provider, which adds functionality that the default AWS provider doesn't have. So it's AWS extras. Currently, the only thing it actually does is it manages our control tower account vending for us. And then we did it's a little simple file we just added to all our Terraform projects that has some good defaults in. Default variables that we use in our naming conventions, standardized ways of how we handle our outputs, that we can reference it between different systems, because even though we are Terraform crazy, we still have other means of deployment, and we want to get handles on the infrastructure and the ARNs and the IDs of resources that's being created by Terraform. So we've got a standardized way to do that as well. So these things together like really cleaned up how we do Terraform in general. And that's actually the end of my slides. Now I want to show you some code and show you like hands-on. Like I'm going to show you some actual stuff. I've created 2 repos in GitHub that you guys can reference. The one is just a sample project it spins up a VPC with a few subnets, and it's got our defaults in. So some of their variable names might look weird. That's like Cloud and Things, our company. It's the shorthands for that. And then I'll show you the workspace provisioner that we use to spin up infrastructure. And that can be used to spin up actually anything Terraform related. It does not spin up other workspace provisioners. There's a bit of a gotcha there that I'll talk to. So if we go into code, so the first thing I want to show you is just the sample repo. And I'll add links to the repos in my talk. I don't think I have it in, and I'll share that out. So very simple. We created this file, that's our cat Cloud and Things defaults, and all our repos have that in. And it's really, really simple. Over time, we'll probably convert this into a module, but there's benefits in having it as just a straight file that someone can include in a code repo. So we've got this is an example of a guardrail, and we used to have quite a few of these. And this is I think it's actually a little bit of a hack to get Terraform to throw an exception, but we used to use this for variables as well. So we would do some checks. If the variable met some condition, it would return a 1, and that could be converted to a number. If not, it returns fail, the word which cannot be converted to a number, and Terraform throws an exception. What's cool about this though is this runs at plan time. So you'll get errors during the plan phase and not get surprises during the apply phase, which is a pretty cool way of doing things. So the specific guardrail we've still got in is to ensure that, because we've got this hub and spoke account or model, that the account that you specify in code, so we've got a variable that we don't use anywhere else, we just use this for the guardrails, that and the actual caller ID, so the Terraform provider, that these two accounts match up. If they don't, you've made a mistake in your provider, so in the variables that you sent in, like the assume role that you want to use. This will break before it even gets to an apply phase. Your plan will fail and you can fix it, which is great. Like, this is a really nifty thing. We've got this in every single code base that we use. So sometimes it doesn't make sense, like when you start interpolating the role in the provider using this variable, then these will always match, but we don't use it like that, so that's fine. We've got some standard tags that we add on everything, even our internal projects like R&D projects, like this thing I'm deploying today has tags, and that just makes it easier for us when we do cost allocation internally, or if we want to analyze where are we spending money, how are we deploying things, and who's deploying things. This just makes it easier. So this could probably be a module on its own, which has our naming standards and our tagging standards. Just this morning, I saw an article, I think it was released today, Terraform, the AWS provider for Terraform, I think it's 3.38, now has default tags in the provider. So this could just be chucked into the provider config, which is awesome. So all your resources will get these tags, with the exception, I think, of auto-scaling groups. And then we've got output. So this is an example for this repo. I've got a VPC ID that I would like to export, and I've got a public subnet that I would like those ons for IDs to be exported. So we define it in the locals block as outputs. You can literally take this thing, create an output resource, use that as the value, and it's fine. But we push it to SSM. So other systems like serverless, and we use the CDK, and we use SAM, so they can all reference this from SSM. So SSM is quite a nice place to store these things. So it'll create a bunch of variables, parameters that you can reference from other code deployment systems. And then we've got a bunch of default variables, and we found, like, we add these things to every single repo. So every time you create a new code repo, you have to either go copy this from somewhere else, or you have to type it out. And then when it becomes a hassle to do things the right way, people stop doing it the right way. So you'll see these variables all have, like, they've got a type, they've got a description, and where it makes sense, they've got validation on them as well. So these are just a few things we have standard internally. And when you, as a developer, copy this, you can totally change this. You can add, like, let's say these namespaces doesn't make sense for what you're doing right now. You can add another one and you can expand it. So that's fine. But it's just a good starting point. And then we use, because these things are standard everywhere, our template for provisioning the workspaces that will, like, ultimately deploy this. It will then, like, it'll have these pre-populated, so you don't have to do a bunch of typing to get these in. So this is like the standard, how would you call it, like a standard that's in all our repos. And then from a variable point of view for this workspace, all you actually had to add is these things. These should actually also be default in our defaults. So that's something I still need to change. So, and then the rest of this is just a sample deployment. So this could be anything. This is just some networking deployment stuff. Something interesting that we saw with for each, which is a bit of a misconception. someone actually commented on a blog post of mine yesterday, is for each only works for known values. So you can't reference things that's being deployed in that same code base, which is it's a bit of a misconception. The key of the thing you are looping on needs to be known, and it's actually quite seldom that key is not known. Like in this case, we are looping across the public subnets which we created, and if you look at how they were created, they're looping over some local variable that we build up. And if you're going to that, you'll see these things are known at runtime, and that's why you can use that. So that known values only applies to the key, and usually the key is known. So that's not an issue. That was just something interesting I saw last night. Cool. Now the interesting stuff. So now you've got your code and you are ready to deploy it. What we usually used to do is like Terraform init and Terraform plan, Terraform apply, and that's it. And no one saw like what are you going to apply? Like there's no second pair of eyes on anything when it comes to apply, or you go and you create a Terraform Enterprise or Terraform Cloud workspace by yourself manually, and it's just you're kind of on your own with that. So we then built this like Terraform automation idea. I don't think it's not unique. A lot of people do this. This is just like our example. So we've got a repo. It's got two folders. The one is our provisioner, and this is exactly as the name says. This thing provisions other workspaces, and it used to be like crazy complicated because it used we couldn't loop over modules, so we had to do quite weird stuff to separate the template files that we pass in the definitions and spin up the different workspaces. Now that we can loop over modules, it became so simple. We just for each workspace definition, we just pass that thing to a module and we loop over the modules. So if we quickly look at what happens here, and this thing is the exception. We do not provision the provisioner using a provisioner, if that makes sense. It's a bit weird, because the danger would be that you could completely destroy everything if that thing somehow got like automatically applied or destroyed. And so this is the one exception where we still we manually go into Terraform Cloud or Terraform Enterprise and we set up this workspace. But this is the only one. This is like the bootstrap. You could totally create this thing through code, but you'll always have something you have to run locally. So, and we used to have that like a bootstrapper that creates this workspace in Terraform Cloud, and you only run that once locally. But there's so little to configure on this that we said it's not worth the effort. You do it once, and it's well documented, so that's fine. We're not automating the creation of this this provisioner. So from a variables point of view, what we need is you need to tell it like to which Terraform Enterprise workspace it will be provisioning. We have a default Terraform version that we want to enforce across all our workspaces. You can override it in your configuration, but if you don't specify it, you'll just grab the default. This OAuth token is for your organization, the OAuth ID that Terraform Cloud and Enterprise will be using to connect to your code. This is not a secret thing, like you can have it, like it can be in clear text. It's just an ID, and you can overwrite that as well in your configuration code. But like I haven't ever had to do that. I use the one from we use the same one everywhere. This you would probably override this if you've got like different GitHub organizations that you're pulling code from, or you're pulling from GitHub and Bitbucket. But for us, it's GitHub. Used to be Bitbucket, it's GitHub now, and we pull from there. Then we've got our AWS key and our secret. And they're set as Terraform variables, and I'll show you why. The key ID is not secret. Actually, you want that to be visible. The AWS secret access key, you want that to be like a Terraform secret. And this is that hub and spoke I spoke about, so that this ID will be in the root account and it can deploy from everywhere. And then when this thing runs, it actually goes and checks. It looks at your Terraform Enterprise or Terraform Cloud environment, and it lists all the workspaces, and it lists all the and it basically does a div on the workspaces that it knows that it manages, and gives you a report on which of these workspaces that you have in your environment are not managed, or not managed at least by this piece of code. And like this workspace provisioner is one of them, so you can add it here as an exception, so it won't report on it. And then that's just, when I say report, it just spits it out as an output. But this is quite handy to see if someone went, because we're not restricting our team members, they can still go and create workspaces manually. We don't want people to do that. And if they do that, we just want to keep track of it and maybe follow up why did that happen? Is it the provision that's not meeting your requirements? And we can fix that. So not a lot of variables. That's why we say like pretty easy to set up. And a variable that you don't see here is an environment variable. And that's one for Terraform Enterprise for the token. It's, you have to just set that because this thing interacts with Terraform Enterprise and Cloud. You guys can go through like the code, it's really pretty simple. It knows about this directory because that's where it'll pick up the template files to provision new workspaces. It does this output of unmanaged workspaces, and we do some data manipulation to get it in a nice format, a nice human readable format. This workspace only interacts with Terraform Enterprise. That's the only provider it needs. I lie, there's more, but that's like the only, the only API it interacts with. And this requirement, I think this doesn't have to be Terraform 14. I think Terraform 13.5 and up should be fine. Cool. And then from a workspace creation point of view, what do we do? So in this directory, we've got an example here. So this is a template that you would just copy, create a folder, or just chuck it in the root of this folder and change it for whatever you want to do. So we have some plans to maybe create a custom provider where it can parse these files and it knows about versions and it will do funky stuff with that. For now, it's version 1. It doesn't do anything. You have to tell it which AWS account you want to go to, you want to deploy to. This can obviously, like there can be many AWS, you can have many providers, but the main provider in our code, this is the account for that. Then if you want, and we only do that actually, is you can say the credentials that's been set in the provisioner, use that in all workspaces that you provision. So if you want to rotate credentials, like one of the problems we had, you only have to change it in the workspace provisioner, run it, and it'll apply to all your other workspaces. So when it's time to rotate, you do it in one place. All other workspaces will get that updated credentials. And then you can say, like, do you want to use the main version control systems credentials, that OAuth ID? Do you want to use that, or do you want to provide your own one? Then you give the workspace a name, you give it a definition or a description, or to apply, like these are like standard Terraform Enterprise and Cloud settings, like which directory do you want to deploy from within your code. So in this example, it's the root. Which version do you want to use? So overriding it, but it's actually the default. Here you specify the repo. So in this case, our repo it's down here. So it's my GitHub. That would be the repo we want to use. and then the branch, which is normally the main branch, main or default we deploy, main or develop we deploy from. Like which other, like we use local modules quite a bit. Like it's a handy way to define blocks of code you want to rewrite, but that's not necessarily shareable. Like it's not reusable for other people. It only makes sense in the context of that repository. So local modules are something we use. We obviously want to trigger a run on changes in that in those modules. And then we've got those default values. So these values I showed you in here, default variables, we specify them in here with defaults. So you actually don't fill this in, you remove what you don't need. There's a few exceptions, like you have to type in some stuff, and you can fill this out. And then like in this workspace case, we've got 2 additional variables that we need to put in, Terraform variables. So you can just copy a block like this, add it in. And if you want to add environment variables, you can add that in as well. So once you've got a file like this, so if we look at this example, this is filled in, and it's got everything we need to deploy this. It's got all the values we need. It's great stuff, and I'm committing this to Git as an example, so you guys will be able to see what this looks like. And here we can see those 2 variables. So we're using control tower. We're deploying to, this is an R&D account, so we actually clean this account out quite often. And this is the session name I want to use when it runs. So how this thing is used is we load up, like we get all the files in this directory, which matches this pattern, basically all these files, and then we convert them to like YAML decode them. And this is where module looping is super handy, where we can just loop over them and pass in like the variables from this workspace into here. And in this module, and this is an example of a module that actually only makes sense within the context of this thing. We've got some guardrails, and these are not the same as the other guardrails. This just makes sure that the YAML file meets our requirements, and you could add a lot more in here. Currently, we only check that the default variables are set. And then like you can add many checks in here. This is just an example of another check. The only requirement is it needs to return a Boolean. And then it sets this flag like create the workspace. It's a binary value. In this case, we don't actually want to throw a Terraform error, because then the creation of all workspaces would come to an halt. We just want to not create broken workspaces, if that makes sense. If we used something like this guardrail we've got in here, this throws a proper error and your work, like Terraform stops. We don't want that. We just don't want this thing to run. What we should add in as well is some output to give the user some feedback that this workspace was not created due to some error.
I think we are over time. We're already 5 minutes over time. If you can quickly round up. Sorry.
Awesome. No, thank you. Yeah. Thank you.
Yeah.
Cool. Let's see. So sorry, I didn't check the time. So if we look at wrong window, yeah. So this is what the workspace provisioner looks like. If I commit that piece of code, it gives a plan like this, and it will tell you, it will create it will create the workspace for you. So we're a bit out of time now to actually show the full plan, but it'll create a workspace for me. And when it's applied, it will give me a report like this, where I've got one unmanaged workspace in Terraform. So that is it. I'm sorry I rambled a bit too much and we didn't get to the actual demo where I commit code and we see workspaces being provisioned.
Hi. Oh, good. There you are.
Awesome. I think we don't currently have any questions in the chat, but there has been quite a lot of discussions there. So if Paul, maybe if you get a chance, you can hop in on the YouTube chats to engage some of the awesome discussions that have been going on. So I think without wasting too much time, we'll proceed to the next speaker. If you have any questions, you can drop it in the YouTube chat for Paul